Good afternoon, learners. Today I'm going to look at the grade 10 paper 1 for November examination. So if you are someone that's in the process now of going through revision, going through paper 1, going through paper 2, and you would like to just get some additional resources, information, you are on the right place. I am going to go through question 1 all the way to 4, which means for paper 1, I'm going to go through analytical, I'm going to go through solid geometry, solids, the cutting of solids, and I'm going to go through 1-point perspective and then civil. So you'll notice that as I'm doing these videos, I am going to put some timestamps at the bottom of the screen so you can see which question I'm busy with. These also might be recorded in succession, or it might also be recorded a few days apart, which means you will in one segment see me wearing certain clothes, and then the other segment I might have something else on due to the dates. So first of all, without further ado, let's start with grade 10 analytical, what you can expect for the November examination. Everything that we are going to go through is going to be examinable content, except at some point during question 4 there's a deviation here or there, but I will discuss it as we go through it. Alright, so first of all, you are greeted with a question and then your instructions here. You're given a pictorial view of a foundation, and then you have a figure down here which is supposed to represent a dwelling, right, or maybe just 4 corners of a wall. So let's have a look and see what the question entails. They gave you the following: an incomplete strip foundation of a non-load bearing wall. There's a non-load bearing wall, and it looks like, by the looks of it, it might be a double wall. Instructions: complete the label by labeling the numbered areas. So here we have a bunch of numbers that points to specific parts of the drawing. Here we have an answering sheet or answering table, and we have to put the answers in here. Complete the hatching for number 1. So there is number 1. It indicates the hatching for the load bearing, or the non-load bearing wall. Yeah, I realize I've said it's a double wall. It isn't. It's a non-load bearing wall, which means it is a single wall. Then we have used the necessary equipment to complete the hatching, right? So this is not a freehand hatching that you use. So answers: first one, number 1, is supposed to be the hatching that I have to fill in on the drawing, right? So this technically means nothing. You can alleviate that. That is not supposed to be there. So typically we hatch with a 45-degree angle. It just makes the hatching look a bit better. So down here, I'm going to start with a line. I'm going to leave an opening of 5 millimeters. So civil hatching is 2 lines. Then you have a decent space. 2 lines again. Decent space. 2 lines again. Alright, so number 1 is complete. I've indicated the hatching on the top and the bottom of the wall. That's all they would like to see. Number 2, it points to this part here, right? So this is, you can use abbreviations or you can write it out on analytical, and both of them should be fine, unless they specify the abbreviation of something or the full wording of something. So here they don't, which means this can be the D, B, C. It can also be the damp proof course. All right, that's what DPC stands for. Number 3, this is a concrete slab. You can just write the concrete as well. Concrete or concrete slab. Number 4, this indicates hardcore filling, right? That is the compacted earth that's just underneath the slab. So that's hardcore filling. And please remember, when you do analytical, you have to use a pencil, right? Your clutch pencil, and you have to write in capital letters, just like you are taught in EGD. 5. This space that's supposed to be here, that is loose earth. So you can write there loose earth. You can write there undisturbed earth. Right, so loose earth. Number 6 is all the way up here. That is actually called the screed. Right, so that is the finished floor level right there. This is where you stand when you're inside of the house. So this is called the screed. In a situation like this, if you label that the FFL or you write the finished floor level, you will still get your marks. All right, but that points to the screed specifically. Number 7, what is the standard size of the door of a door in millimeters? There's a few concepts in civil that you just have to know. It's always beneficial for you to know the fixtures for any fixture that you find in a bathroom, the doors, and some of the window schedules. It's standard, especially the foundation for normal houses, the width of a double wall or a brick. It's always beneficial to know these things from the top of your head. So the standard size for a door in millimeters, it's going to be 900 millimeters. You don't in this case have to write millimeters, because we assume and we acknowledge that whatever number you write down here is already going to be in millimeters. Unless they specify this in meters, then it means you have to add the meter sign there. Now, calculate the surface area of figure 1 in meters squared in the space below. So this is now, I have to calculate the area inside of this figure here, right? So here they give you a measurement from this corner to that corner, it's 6,000. From this corner all the way down here, it's 3,000. So we know that in civil, these represent millimeters. But whenever you do an equation or a formula in civil, we have to transpose these numbers so they represent meters, right? So this distance would actually represent 6 meters. This one would represent 3 meters, all right? So in order to work out area, the formula is area equals length times breadth. So in this case, it's going to be 6 meters times 3 meters. Do you see we are not using the 6,000 and 3,000? We have converted it to meters first. So now it's 6, 12, 18 meters squared. As easy as that. For this, you would get your full marks. Typically, you get 2 marks for the answer and the unit of measure. That's only given if the answer is correct. Otherwise, you don't get any of these marks. And then if you have the formula or a multiplication sign, you get 1 mark there. All right, so this is analytical in a nutshell. You can expect the same type of deal in the end exam. So best of luck. Stay tuned for solid geometry, question 2. Right, we are looking at solid geometry for grade 10s. So currently this is an examinable question. We are looking at question number 2. We are busy with paper 1 for November examination. The front view and auxiliary view of a right regular hexagonal pyramid has been given to you. All right, here you can see the pictorial view. Cutting plane AA and BB. Here you can see a horizontal cutting plane and a vertical cutting plane. Instructions. Use the given information and complete the given front view, which is this view, that's the front, the sectional top view and left view. So that means we have the front view here. It's first angle orthographic projection, which means to the right of it you will have your left view, and at the bottom you'll have your top view. All right, so the given front view and the sectional top and left view. So the left and the top view is going to be cut by the respective cutting planes. Note, show all constructions, show all hidden detail. So here you can see I've already given you the auxiliary view. I've already indicated you the labeling process that you have to follow. So just by using the initiative, we can use 1, 2, 3, 4, 5, 6. The middle point here, because it's a pyramid, we can label top. So now to find out what the angle is, I'm going to show you a bit of a trick. Let's say, for instance, on this drawing, there is no degree given to you. I didn't give you a starting point here or anything to use as a reference. Remember, the pictorial view is always going to be a scaled down true representation of the drawing. So you can grab one of your set squares and you can line it up to a corner to see if it adds up to the other ones. If it does, then you know it's going to be a 30 degree. So in this case, it is a 30 degree. So if I put my 30 degree angle on 1, it should connect up to that point there. All right, so let's see. So in a construction line, you can see it lines up perfectly. So this is going to be a 60 degree angle, and then you just connect all these points up to the base. All right, so here you have the base measurement. It ends all the way there. The middle point top still has to be determined. So there's the middle line. So on this line, now I go ahead and see, all right, so the distance from here all the way to where top or the apex point is, it's going to be 75 millimeters. So 75, make a little mark there. Remember, the front view is a copy piece. All the way up to there. All right, remember you are looking at the auxiliary as it moves onto the XY and it just falls over, which means the lines that's supposed to go up here is going to be 0.6 and is going to be 0.5. You have to copy the shape as it is so you can see it's given to you as an A quality line here. All right, so that's 1. That's 2. Right, then we can go ahead and we can draw the base of this pyramid as an A quality line. And now we actually have to draw the cutting planes in. Right, so this is also quite an important part of the drawing. First you have cutting plane AA, which is a horizontal one, which you can see starts exactly here, and it's horizontal. B starts here, and it's vertical. So the first one is going to be here. Now remember, these drawings really don't get you a lot of marks, the copy piece, because it's expected that you will be able to do this with no problem. So just redrawing this is not going to give you a ton of marks, but it's a good start. So there I have the cutting plane. Now I just have to thicken the end lines. So in order to draw a cutting plane properly, we always thicken the end of the line around about 4-5 millimeters. Just so there's some sort of deviation on the ends of the line, right? So here as well, 4-5 millimeters, just thicken the line a bit, and then we draw in the arrows there. So 1, 2, 1, 2. Right, and then you just thicken the end of the line so it gives the illusion that it is in fact an arrow and not just a random line that's there. All right, and then we label it. So A, this one is B, B. So there I have my copy piece done and dusted. Next, it starts projecting for the top view and it starts projecting to the left view. So I'm going to do the top view first. I always find it easier. So in this case, all these points have to be projected down. I almost forgot to label. So as soon as the auxiliary falls over the XY, I'm looking at 0.6. At the back you have 2, Looking at 5, at the back you have 3. This is going to be 0.4, and that is going to be top. Alright, so here I already have an XY axis that has been given to me. If it is not given, just draw it in so it doesn't overlap with your auxiliary or with any other part of your drawing. So all of these points, point 1 gets projected down, 6 and 2, 5 and 3, 4, and top. And now this might be where some of you might fall out of the bus, but before that happens, we are going to stop it. Okay, so by grabbing a piece of paper or your compass or any ruler or anything in that sort, you are going to do the following. This XY axis is going to represent this XY axis as you traverse and you project the points over. So what I mean by this is you're going to line up a piece of paper starting with point 4, right? You're going to make a mark where the XY lines up with the paper, and you're going to label this X, Y. This point then goes onto here, which shows you on line with this you have 4, top, and 1. So this will represent 4, top, 1. Next, you move it so the XY still lines up with point 3 and 6. So the XY still has to be in line with the XY here. That is now point. This one is point 3 and 2. This one is point 5 and 6. So now I have all the points on here. So now this XY, you remember what I said not a minute ago, this XY is going to represent this X1 and XY1. So now you go ahead and you have a look and see where's point 1. It goes down, so this line is line 1. So you put the X onto the XY, you have a look and see where's 1, it's in the middle, so that point there, you just bring that point over, and that becomes 1. You see? So now we have 6 and 2, so XY. There's 2. There's 6. So as I'm making the point, I'm labeling it 6, 2. That way you don't get confused. Then you have 5 and 3, which is here. So 3, 5. And the last one we have here is 4. And then we have top. So now you've successfully brought all the points down onto the top view. Just going to zoom in a bit more because we are not going to use the pictorial view anymore. We are now just focusing on these views. All right, so in construction, you are going to connect these points together. So 2 goes to 3. 1 to 2. 1 to 6, 1 to 4. Remember, there is going to be some hidden detail that's present in the drawing. I just want you to see the shape, project the shape, all the points up to the top, and then we'll look at what's going to be hidden, what is not going to be hidden. So if you're someone that already knows what's happening here, you can just skip on to the next part. Just for the sake of getting through the drawing, remember this was 2023's exam paper, which we are going through at the moment. So your exam might differ slightly. So just be aware regarding these. I've already dealt with solids on the channel. Just go and have a look at some of them where the true shape is also being discussed. That might also assist you. All right, so if you are looking at it from the top now, which is the one we are busy with, everything above the AA line falls away, which means the first point that you're going to see is going to be this one, 6 and 2. So if it cuts on 6 and 2, it cuts through the base. What happens if it cuts through the base? The shape changes. So if it cuts through there, it means it cuts away point 1. That means that line that comes down is going to be an A quality line. I know this, right? Then it goes all the way through and cuts there between 5 and top and 3 and top. So if that line comes down, where should it go? 3 to top, 5 to top. Right, so I'm lining up that point. There's 3, there's 5. Alright, so usually we'll give a letter, we'll assign a letter to these points. So it's easier for us to now just label it AA, BB, and CC, and so on. So the last point where the cutting plane A cuts is there on 4. So if you project 4 down, or the last point, it has to go onto point 4. Alright, now, before we even draw in the cutting plane, let's see what's visible and what isn't. At the very bottom of the drawing, remember you are looking at it from the top like this. So you won't see point 4 as it goes to the top. That's hidden detail. 5 and 3, so on the base forms the shape of the drawing. So 4 goes to 3, 4 goes to 5. That will also be hidden detail. So as it stands, 4 going to top, 3 to 4, 4 to 5. That's hidden detail. So if you have to draw it in, and remember, usually you do this beforehand, you work it out. It makes your life a bit easier. So here you can see the hidden detail. I've only drawn it up to here because once you have your cutting plane and you've indicated your cut, you can connect the dots together. Right? So this point goes back to there. This point goes back to there. Alright, so that is the form that the cut is going to take. That is me removing everything that's above the cutting plane. So I won't see this line here anymore. So you just leave all of these lines in construction. You won't see 2 going to 1 and 6 going to 1 because you can see it has been removed. So the rest of the drawing, that's now A quality. So only now you get to a place where you draw in your A quality lines. So hopefully at this point, everything that I'm doing now isn't foreign to you. If it is, best of luck, because you already had to deal with this during the year. So there is enough resources. Just go look through the stuff. You can even copy the drawings and do it with me. All right, so the segment, or the hatching, sorry, is going to be the same story. We're using a 45 just because it always looks better. There's no rule that actually implies that you have to use a 45 to hatch. We are doing it because in the majority of the drawings, it fits and it does look better. All right, so that is the top view. Remember, this is the front. That's the top. This is going to be the left. Alright, so the left view is going to work exactly the same. Once you have this, you can reuse it for the left hand side as well. Right? You can just take the points and project them the same way. You can go ahead and draw a 45-degree angle down here, project all the points onto the 45 and then up. It's going to be the same. So for this sake, I'm not going to do the 45. I'm just going to use this piece of paper again. So I'm taking all these points, 4, 5 and 3, 6 and 2, 1, and the top. Projecting it over onto the left, right? It's because it's first angle orthographic. Then I'm grabbing the XY. So it lines up with the XY here. See the vertical XY axis? So it lines up there. This is in line with top. The second one is in line with 1. This one is in line with 6 and 2. Right, so line it up. That's 2, 6. This one is 5 and 3. The last one all the way at the bottom is 4. The most important part is that you remember the XY has to line up with the XY, and that's it. You can also grab your compass, you put it on the point you made on the XY, let's say onto point 5, and then if you take this from here, it should add up to exactly the same. Okay, so you can use either one of the ways. So here we are going to do the same. We are connecting all the letters together, right? So 1 and 2, 5 and 6. Remember, it's construction. 4 and 3, 6 and 1. 5 and 4. 1 and 2. So once you've connected all of those points, they also go to the apex point, right? So they also connect all the way up to point T. So 1, 2, 'Alright, so that is the shape that you have. Remember, we are now looking at the left view. That's us looking at it from the left. So this should already tell you, if you look at it from the left, you are going to see the shape, the base first. That means from point 1 to the top, point T is further towards the back. So this 1 is closer to you than what that point is, if you look at it from the left-hand side, right? So that indicates that this line here, if I didn't cut anything, would be A quality. So technically, this line that you see here, from number 4, is supposed to be hidden detail. Okay, so I know this for a fact. That's hidden detail as it goes through, because you only see the corner, you don't see the line as it goes up. All right, so starting with this drawing, now we are using the cutting plane B. Because if you use A, it means you're just going to draw a straight line here, and everything above it gets removed, and there's absolutely no detail to the drawing. So in this case, we are using B, which means point 1 goes to top. If you take point B, it goes on to point 1 to top. So making the first mark there. Secondly, it goes down and it cuts here on 6 and 2. 6 and 2 going to the top, so there's 2, there's 6, so it cuts on the sides. 2, 6, then it goes all the way down and cuts on 5 and 3. So the rule is, if it cuts on the base like it does here, then the shape changes, which means you are going to have a straight line through point 3 and 5. So again, if you look at it from the left hand side, you will see that 3 and 5 actually goes to 4. That line is still visible to you. So this line here at the bottom is A quality. That's part of the original drawing, and then the cut happens above it. So 3 goes onto those points. All right, so here you made the segment, the cut rather, and then both of those 2 points goes onto here. So you can see the majority of the hexagon shape, the base, has actually been removed from this drawing. So even though we have the shape here, nothing of that is going to be visible anymore. That entire line from 5 and 3 all the way to 1 has been removed. So you don't see anything regarding the shape anymore. From B, from there, all the way to top, if you were to draw a little line, I'm just going to indicate this to you. If I draw a line to the left, do you see from point B to there, there's a bit of a distance. It means as this line is on an incline going up, you are still going to see that. So 1 going to top, is still an A quality line. You see how we are breaking this up in segments, little bite-sized pieces. So B to top, that's an A quality line. That's what I have. From 6 and 2, from this point to the top, it's still visible to you. So there is the cut from 6, and there is the cut from 2. So 5 and 3, those lines still go up to the top, but now they are behind the drawing. So what happens with these two lines as they go to T? It becomes hidden detail, right? So 3 and 5. And then everything that's in between here, from here, that shape is going to get hatched. So I'm going to use 45 again. I'm going to use 5 millimeters. And please note, I'm not erasing anything on my drawing. Leave the construction lines, leave the hidden detail, leave all the information on the page that shows how you got to the answer. All right, so this would be, according to your instructions, you've done the given front view, that's a copy piece, and you've done the sectional top and the sectional left. So this is solid geometries in a nutshell. Next, we are going to look at
what did he say?
Perspective, 1 point perspective to be exact. See you there. Now looking at the perspective, the first thing that we see is the front view and the top view of a dwelling. Here's the top view above the picture plane, and the front view is directly on top of the ground line. Use the given information to complete a 1 point perspective dwelling, or drawing of the dwelling, sorry. Alright, so 1 point perspective means we don't have 2 vanishing points, we only have 1. So the vanishing point is always going to be determined by the SP. Now this is called the standing point. So if you look at the SP, it's always going to be the starting point that you have to use in order to determine the vanishing point. The vanishing point cannot be on any other line except the HL, the horizontal line. So that means I'm drawing a straight line from the SP in construction onto the HL, and that point there becomes my VP. You have to label it. That indicates a vanishing point. So now we can start the drawing, right? We're going to divide this house into 2 parts. We have this back part of the house, and then we have the front part, which is here, which is what we see. So this is supposed to indicate the window that you see in the front. That is supposed to be a long window, and then you have a door there that's situated on top of the step that's also there. So this house is going to have a little porch in the front, and then it's going to have the 2 windows with the 1 opening going into that back room. So the first thing we do is we have to look at what touches on the picture plane of the top view. So I can see part of the porch is connecting onto the picture plane, and these 2 walls of the house plus the window. So if you project those points down like this, then you already kind of start getting the shape. In between these 2 you're going to get the dwelling or the walls, and in between those 2 you're going to get the porch. So the height for the porch is always going to be gotten from the front view here. So you take the height, right? I'm lining it up with the first step, or well, the porch height, and I'm projecting this across. So drawing a line in there, you can see that is actually going to act as the starting point for my porch. So technically this line will not be here. How do I know this? That little line that's supposed to go down, because I can see on the front view, the pictorial view, it isn't there either. Alright, so firstly, we can take the height for the wall over as well, because we've already projected those points down. So it's going to be here. A quality line for the wall. So in a situation like this, I would always suggest that you copy some sort of front view or some sort of shape that you have, which you can then project back to kind of get the 3D shape that you need. So from all of these points, you draw a construction line to the VP. If there's a bit of noise outside, I apologize. I'm going to try and alleviate that. Alright, so if you project all these points to the VP, except that one because I'm going to have a roof in the way, now we can go ahead and we can start determining how far is the porch actually going back. Remember, the top view is there to determine the length of the drawing, so how long it's going to be. The front view is there to determine the height of the drawing. Alright, so in order to determine how far, the length, far indicates the length the drawing is going to be. You can see there is the starting point that I have. So that point goes all the way onto the back of the house, which means that point goes to the SP. And this is where you have to realize all the lines on the top view has to go to the standing point, and then it has to stop on the picture plane before you bring it down. So on the picture plane, now I have the point which is here. So I can bring that point down, and this is where the step ends. Or well, the porch. So in a construction line, I'm going to draw in that little line. Just for a bit of clarity's sake, I'm going to remove this front line, just so we can see what's happening here at the back. So that is how far the porch actually extends towards the back of the drawing. So in front of this, according to my top view, I'll have a step. So I've just determined this point here as a construction line straight through, right? But I still need to add a step that's supposed to be here. So if I take this point of the step to the SP and I bring it down, so this point onto the picture plane and straight down to here. So where that connects here, that gives me the indication where my step is going to start. So this line that comes down is supposed to extend. So if you take this point to the VP, extend it, and now you can actually get the width of the step. Picture plane, or the SP stops on the picture plane, comes down, and now you should already start to see the shape that's forming here. Okay, so now you can already see the lines as they go back. There is still part of the porch, and there the step starts. So what is the width of the step? I'm going to take this point because I've already determined the left side. Okay, this point goes all the way there, project it down. Where that connects on the step, that is where my step is going to go. So in order for me to determine the height of the step, you can do one of two things in order to get this. I can project the step height onto this wall, project it back so I have it at the wall at the back, which is supposed to be here. Project it into where the step is supposed to be, and then into where the actual step is. Or you can project it here to the front, which I'm actually going to do. I'm going to use a different method a bit later on, which we will discuss. But for now, I want you to see this. If you have a little construction line here, the lines that already touches on the picture plane like these are called height lines. That's why I can project them down from the start and actually start getting the image, because I can directly measure the height onto a height line, and then I have it. So I now am going to take the step onto this hypothetical height, or this height line, right? There's the height for the step, that step. You project it back to the VP until it connects there at the back. So now I have essentially the height of the step there. That point goes over horizontal until it connects here. So there, that point, that is now on the step itself. So now I essentially have the height for the step. So you can start drawing that in A quality. Right, I'm just darkening the lines so we can see exactly what we are working with and what we have done so far. Alright, so this is going to give you the indication. What I've done, the step goes onto the height line, so that's the height for the step, goes to the back where it connects here on the back line, right, so it's in line here. Then that point goes over to the right until it connects onto that inside point of the step, and then I can just start projecting it so I have the height. This point can now be projected also to the vanishing point. I'm not going to project it all the way because I know it has to stop in line here. Okay, so later on we are going to do something with that. But for now, that's how far it goes, which means I can now draw in the corner here at the bottom as well. Alright, in order to get the height for the wall at the back, this is now an example of the height line. So for instance, we already have the height for the wall here onto the front, which the majority of people understand. But now as soon as the height goes to the back, it doesn't make sense. So I'm taking this height, projecting it back onto the back wall. So you'll have it here. There you have the back wall. So that is also going to give you the indication. This height is here. Now you need to determine this point. So I'm now busy with this line. So if that point here goes over to the left, so all of a sudden, the majority of the drawing is going to start happening. I just realized this line is not going to be dark. It's supposed to be light still. Alright, so that's the only dark line. That line is supposed to be construction. So once you have this, you can start projecting this point to the back so we can determine how far the drawing actually goes back. That's where we take the width of the back room. Right, so now we take this back part to the SP. And now that gets connected all the way onto where the porch point is. Alright, perfect. So now you have a majority of your drawing already done. The roof is next, and then we can look at the doors and the windows. Alright, so in order to get the roof, this one is connected directly in line with where the wall is, whereas this one isn't. That actually, this implies that this part here is also going to be, should not be an A quality line also, but we'll get to that now. So in order to get the roof point here, we are going to create a height line for the roof specifically. So I'm taking this point straight down, right? This is a height line. Then I'm taking the height for the roof. So there is the apex point, and I'm making a mark on that height line I just made. So typically you would just connect these points up to there if this point was on the picture plane. But now it isn't, right? It's slightly moved away. So this point now has to go to the VP. So on this line is where I'm actually getting the height for the roof. So now you take this point to the SP. You see there is the line on the picture plane, and from there you bring it down, and that is actually where the roof is now supposed to go. So height line, back to the VP, taking the actual roof to the SP, and where that comes down is where I have my point. Alright, so you already have the line of the roof as it goes to the back. So this is the line I have. So that point is the one I need to determine how far the roof goes back. Okay, so taking the point, projecting it down, so all the way up to there. So just for now, we're going to leave the roof as it is because it has a point at the back that's supposed to connect down to a specific corner. We don't know what it is yet. So for us, we can now take this point of the roof to the SP, connecting on the picture plane, project it down. So somewhere on this line here, I have my roof point. How do I get the height for the roof? We need to have a reference point. This line that we initially started with. This line here, where we took the height for the step as well. You are going to take the roof height and you're going to put it on that same line. Alright, so there's the line going up to there. That point goes to the vanishing point, where that intersects on that roof line I just made. So this goes back, and where that intersects with this point, which is the roof point there, that is where my roof connects to. Right, then you can see the roof is horizontal here as well, which means from this point, construction line, then we can go ahead and take this point to determine how far the roof goes back. Okay, that point lines up to the roof, so goes up to there. And then this point of the roof actually goes down to the corner here. So it's going to look like this. But now I have a big open space up here. Right? So this back corner, you can see there's the roof and it connects to the back point there. So it's this point on this line. I need to determine this point here. And then that point goes straight down. I'm just making a little mark there. So technically the back side, you can also take this point back and it should connect on the same. So now I'm lining the roof up to that back point. And I'm just drawing in the last bit of the house that you would see there. So obviously it's going to go behind this part, which means you don't draw a line there. Alright, now we get to the windows. So this first window is just a line that goes here. You can see I'm not going to draw in the whole everything. Then I'm taking the window, the hidden detail here, and I'm just extending these lines down. Right, there's the window. But now obviously this window is also going to have depth to it. You are going to see the frame or the sill, which means you're taking this point to the VP and you're just extending a bit of a line. Obviously it's not going to be that big of a distance. So I now need to determine this width, the length. So I'm going to take this inside point, SP, and you can see it's not that big of a distance that it makes. It only goes up to there. So that is going to give you the inside frame. Then it's a straight line. Every straight line that you see on your top view is also going to be a straight line on your drawing. Alright, then we have to assume, it's actually quite, if a drawing is given like this, at some point you cannot just use this corner here to indicate the windows or the sill that you see inside of a house. So what happens is we usually take the height, the first height that it connects onto, which is going to be the step, and then we take, or the porch, sorry, my words, and then we take that back. And now you see the inside sill, right? So that's the back wall. For the door, same principle applies. I'm going to take these 2 points, right, the hidden detail, down to the SP, I'm already going to take this inside point of the door, right, the width. Line it up, and that looks like it connects exactly on the middle line there. So if I project those lines down for the door, it should be this one, and it should be that one, and then the inside frame is going to be there. So I have the frames for the door here, but I don't have the height yet. So the same principle applies. I'm using this one line for all the heights. So you take the door onto this initial point. So there's the height for the door. That goes to the VP. Where that connects here at the back, it's going to be on this wall, right? It's most in line. You can see everything is in line with one another. And then this point just goes over to the right. And that gives me the height for the door. The door also going to follow the same principle from this corner here to the VP. Alright, and now you can go ahead and that step that was left in the hidden detail, just fill that in. We tend to leave this space open. At the bottom here, you will not get penalized if you close it off as well. The last thing that we do is we take in this case again, it's going to be difficult just for the sake of this drawing. I'm going to take the porch, extend it to the back, and that is going to act as the inside wall. So there I see the inside wall, that's still part of the floor. Alright, we have one more part left. It's going to be the window here. So the height still applies. This is the height line that's closest to the window. Right, so the window is the same height, so I have it on the height line. Those points just get projected back to the VP. And just like that, you can project the window points down. The width of the window as well. Right, so here's the first point of the window. It's convenient that it's already in line with one of my other lines. And then this point. And lastly, the inside, which determines the width, I only indicate with a little line there. So that point is also going to be here on the inside. And because there's a horizontal line there, we also draw the horizontal line here. Right, so if I take this point, that wall, that back wall, and I take this one, and I bring them together, is there any chance that they are going to meet? None whatsoever. So there might even be a chance that this back wall goes down and connects somewhere. So you'll see part of the back wall here. Or it might not even be. And that means you'll only see that little back part. Alright, so that is your drawing. This is perspective in a nutshell. If you can do this, you can do in any one of them. The heights are quite important to navigate around, the step, and the windows with the width and the doors. So all in all, go through this, listen to this as many times as you need. Get material online. Ask me for material, whatever you need to be able to practice this and get it done for the exam, do that.
What did he say?